Okay, now, so I just had a little rant with the class. We don't need that on YouTube, or else might get less views. Right? Want to get as many views as possible. Well, might get more views. Throw a tantrum, maybe, and then maybe we'll see. Keep making comments back there. Maybe I will say something. All right, so here we go. Now, put the magic Ferris wheel in your notes or not. I couldn't care less. By the way, did I ever talk about this? Could and couldn't. Do you ever hear someone say I could care less? You know what that means? That means here's the caring graph. Okay? If I could care less, here's 100% caring. They actually could be at the 100% caring level. So if they could care less, they could be anywhere along this graph. I get in that person's face immediately. Oh, you could care less, huh? So that means your caring level must be at 100%, and you could get somehow be lower than that. When they should say that I couldn't care less, which means their caring level is at what? 0. It drives me nuts. You know how many people say could care less? It's like every time. Every time, which makes absolutely no sense. So that's how I'm going to start this video. So I couldn't care less if you don't take notes. But you are setting yourself up for failure in case I had like an open note quiz or whatever. So it's you're adults now. You're juniors or seniors. All right? You own your own education. It's your situation. Now, do we need the Ferris wheel? I kind of think you should, so you get a feel for the next 2 days and some differences. So whatever. This magic Ferris wheel is this. Obviously, you see that there's seats here, so there's nothing magic about that. But what I'm going to do is, you know what? I'm going to put seats on the blue circle as well, and then give you a choice. Which seats do you want to be on? The seats on the blue circle or the yellow circle? Here we go. This happens every time. That little symbol. Well, what this deals with is speed. And the two distinctions I'm going to make today are hugely important, and you need to listen. All right, and then you'll figure out, the big things for the day. But honestly, today's homework is just, formula usage. But I would like you to have a good feel for what the formulas mean by what I'm covering right now. All right. What's speed? It's blank over blank. Distance over time. But you know what that is? That's actually called linear speed. And I just missed an A. Linear speed. Linear speed. Why is it called linear? I'll explain it with the circle. Linear speed is a distance traveled. A specific distance traveled. You know this. You're like, why am I writing this down? I hope I spelled that right. I feel like there's 2 L's in traveled. Really? This is math, not English. Let's move on. Over a specific time. Everyone knows that. So how does that work for the Ferris wheel? I'm going to do some numbers that we did last hour. And let's just do the normal. What did I do last hour to make this work out? Let's say that this distance from here all the way to here, that's, what's that called, by the way, for the circle? No. That's rotations. Okay, and actually that's going into, but what's that called for a circle? Circumference. Let's say that's 48 feet. And so you traveled 48 feet in 6 seconds. What's your speed? I made it easy. Oh, no. 8 feet per second. Just 48 times divided by 6. I'm not covering that. Okay? All right. Now, here's the difference between the blue and the... Let's say the blue is only, let's make it easy, 24 feet for a circumference. What's their linear speed then? And I'm kind of giving away already what I didn't want to. 4. Oh, that was interesting, 48, 24. 4 feet per second. So if you pick the blue seat, do you travel faster or slower when you do one rotation? Slower. See, here's the problem. When you do one rotation, this is 48 feet that you traveled over 6 seconds, whereas I said this was 24. Obviously, it's smaller, right? Right? Isn't the blue a smaller circle? But they complete the rotation at the same time, right? Because you're stuck on this arm. So if you sit in the blue set of seats, you travel what linearly? Slower. And because I did 48 and 24, it's half the speed, obviously. A little proportional relationship here. But here's the situation. Nice. What's the angular speed? What? Angular speed is angular displacement or angular change over time. Displacement just means change. Hope I'm spelling this right because I'm trying to do two things at once. Like chewing gum and walking, I trip often. So, what's the angular speeds of these? All right, let's stick it with degrees. Degrees only. What's a rotation? 360. And then how many seconds did I say? It took how many seconds to go one rotation? No, I said 6 seconds. So, what's the angular speed of the yellow? 360 degrees for 6 seconds. What would that be? Don't touch that calculator. 60 degrees per second. What's the angular speed of the blue? No. 6 degrees per second. Why? Why are they both 6 degrees per second? Because they did one rotation in, how many seconds did I say? 6 seconds. So the angular speeds are what between the two seats? The same. I love this example to get you to understand the difference between angular speed and linear speed. Now, why do we call it linear speed? When you hear the word linear, what do you think of? A picture of a what? A line, a straight line. That's like saying a male boy or a female girl. All lines are what? Straight, right? You get what I'm saying? It's like what do you call that? Redundancy. Anyone know? Okay, I'm going to pause the video. Everyone's looking at me like I'm weird. It happened. Okay, all right. So you know what you could do? We could pretend the circumference is a string, and we could get scissors and cut that string, and then do what with that string? Lay it out in a line. So that's why any distance you travel, whether it be circularly or like a winding road, that's when, if you have like a thing that measures your distance, which I do, like on my iPhone when I ride my bike, it's getting your linear distance if that not linear thing was a line. So anything can be considered a linear distance, even if it's not a line that you're traveling. So cut that circle, lay it out like it's a string. That's the distance the yellow traveled. That's the distance the blue traveled, because I knew it was half. So that's why I drew that the way it was if you cut it out. So again, I just wanted to exercise the word linear. All right. Now, some of the stuff that I have in the notes, I'm going to cut out. And I know, a lot of my stuff that I do, I try to climb into your brain. Don't shut me out. I'm not going to look at this picture. We're going to get rid of this. But, we're going to talk about the things that we just said. What's speed? In your mind, speed is a distance traveled over time, but it's not going to be always. It's going to be also called angular speed, which really is going to be rotational speed over time, which has nothing to do with distance. It's just how fast you rotate over time. And just like that previous example, they both had the exact same rotational speed, but linearly, the yellow seat's funner and faster than the blue seat. I personally picked a blue seat because I might throw up in the yellow, because I don't like going in circles. Anyone like that? Yeah, don't admit it. People will make fun of us. So what's distant? D equals RT. What's the D? Distance equals, what's R? Rate. And then what's T? Time. This is just another incarnation of what we wrote up there with different letters. Just try to get you familiar with, stuff that you dealt with before. All you have to do is divide both sides by T, and there you go again. Rate equals distance divided by time. That is more the linear thing. Now we're going to see this real quick. I'm going to see if anyone can figure this out. I'll wait. I'll just come down here and actually shove these formulas in your face. Okay, so here's the first thing. We have to today actually, what I'm talking about today compared to the tomorrow puts everything all together. But today is just formula usage. It really is. But what I would like you to be able to do is when you look at the formula they ask you to deal with, know what it is. So the first one is angular speed. Angular speed is angular displacement over a time period. In angles, what's that letter called? Theta. Usually use that for radians, Greek letters like that, or just angles in general. And then look at this thing. You just have to understand that. What letter does that look like? But it's a little fancy. Fancy W. So what you have to understand is when they ask you W equals, that's angular speed. Okay, so all this written here, you just have to be familiar with the formula today. Tomorrow we're actually going to use it, and you better be ready to, depending on what they ask you. All right. All right, here's the chart. Okay, and then actually, you know what? I want you to focus because someone just held their head like, oh my goodness. All right, let's just get rid of this first. Just look at the other side. Okay, we already talked about that. So figure this out in a chart. Draw a line in the sand. Psh! The thing on the left is related to the thing on the right or helps create it, but they're completely different. On the left, we just wrote that. Angular speed is angular displacement over time. Okay, in my example for the Ferris wheel, I'll use degrees. Somebody did say it, and I shut them down. I'm sorry, you were right. What's one rotation in radians? 2 pi. So if you go back to the Ferris wheel example, both of their angular speeds was 2 pi radians over 6 seconds, right? 2 pi radians over 6 seconds is where I want to throw a chair. 2 pi over 6 is what over what reduced? Pi over 3. Thank you. Radians per second, right? 2 pi over 6. No, actually, yeah, it is considered pi over 3 radians per second because I reduced it and blah, 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 blah. All right, we already have a question. All right, this is one of your question was actually, is it always going to be in radians? The answer is yes, because I know you're going to hate this, but those that didn't get this before, fine. Look at all those notes. Look at what is that, a picture of Earth? Holy jeez. Anyone see that? I almost fainted. All right, any circle, I don't care. Pick a number and a label for that radius. Then make it kind of 7 what? Inches, fine. Guess what this is? 7 inches. Guess what this angle is right there? Come on, I should put this on the test. 1 radian. That's what 1 radian is. So the reason I piggyback this off your question, radians come from labels. Radians are derived from labels. So magically, when you do dimensional analysis, and you get rid of the labels inches, the leftover angular velocity or angular, the angle left over is radians because radians come from this. It's hard to really understand that. If I take a radian and multiply it by a label, the new thing is that label. So if I take a radian times feet, now you're in feet per. It's just magic, but it's not. It's because of how they're derived. Really, you have no other way to say that. So to answer your question, holy cow, a guy on a bike, did you see that? Yes, it's always in radians because then we can convert it into linear speed and put it in feet, miles, inches, seconds. All right, now let me review. Don't look. Everyone, close their eyes. Everybody, close their eyes. If you're not closing your eyes, you're anti-educational. Okay, now let's go over here. And actually, this is a look, and you can look. Okay. All right. Now, what's linear speed? Now, the distances we're traveling in this section are circular. So we're talking about Ferris wheels. We're talking about gears connected, which travel circular distances, right? Pulleys, a pulley example. One pulley is generating another pulley. One's big, like a bicycle, right? A bike. You have a bike chain, okay, and the chain's connected to 2 different circles, which are the gears, right? Gears. Chain gears. Okay. So, hey, what is S? S is called what? Arc length. So, wouldn't you agree that the velocity linearly is the arc length divided by time, right? So there's one incarnation of linear speed in a circular motion. Whatever arc length you travel divided by time. But wait, what is arc length? S equals, what does that say from our section 3.2? R theta. So all this is a rewriting of that formula above. It's not a big deal. Right? So what you just have to be aware of is there's three different ways we could write linear speed, and I'll show you the last one. Now the last one I've had highlighted in yellow. What did we just name theta over t? What is that called? What letter is theta over t? What letter? What letter? W. Huh? So I can replace theta over t with w from the other side of this situation. So what this tells you is this. It tells you, fine. In a long way of doing this, if I knew the arc length that I traveled over time, I'd be able to get the linear speed. If I didn't, if I was given r, theta, and t, then I could plug them all in and find the linear speed. But what this really tells you is if I know the angular speed, all I have to do is multiply it by what? The radius. Because according to this example before, does it matter how far you sit from the center, yes or no? Yes! Linearly or angularly? Linearly. Let's go back to this and put a person right here. What is a person that's standing right here? Oh, for the love of dog. I hit it twice and it... Oh my... I'm going to punch this... Okay, sorry. What if you're standing right there? Alright, what's your angular speed? 360 degrees in 6 seconds. What's your angular speed? 6 degrees, but what do you just do? You just spin. What's your linear speed traveled over time? 0. Isn't that fascinating? So the point is, the farther you sit from the center, what linearly? The faster you travel. So the reason I wanted to cover that is, that's the incarnation of this. All our angular speeds could be the same on the Ferris wheel. How far we sit from the center gives us different linear speeds. And that's definitely true in this magic Ferris wheel question. All right. With all that being said, all you're going to do is questions that deal with the formula. And I'm going to yell at you for not knowing your fractions. Yell, yell, yell. Like I said, I should start it in August, a 4th grade math book over in the corner. And you cannot start this class till you finish that 4th grade math book without a calculator. Yeah, because it's those fraction rules that are just destroying students every year in CAT. And I swear to dog, if somebody, still, fights and doesn't learn these fractions, you're causing your own problems the whole year long, including next semester. So, calculator. Okay, calculator. Here we go. What's this formula? W equals. This is what I mean when you're doing your homework. What's W? Angular speed. This is an angular speed question. All right? But all it is if you notice, this is just plug in and solve for the leftover. Can you deal with this formula mathematically with fractions? So what do I put in for W? What do I put in for W? 5 pi over 27. Don't be touching your calculator. These will be on the no calculator part of Tuesday's test if I have it. Equals. What do I put in for theta? 2 pi over 9. Over what? T. Now, there's a couple ways of doing this. The fraction masters will know where this... Nah, I'm not even going to say it. I think this is the best way to do it. We have this over this. We have this over what? 1. Why did I do that? Those that know what I'm going to do next? Cross multiply. Now, I asked a silly little question, and the first person that answered got it wrong. So think about it before you answer. But 5 pi over 27 does get multiplied by t. Now here's my question. This is your first fraction test. If I forced you to put t in the right spot, I'll give you 3 choices. Does t go in the top? Don't answer. Does t go on the bottom, or does t go on both top and bottom? Man, that's amazing! You did the same wrong answer that the person second hour did. If I put t in the top and bottom, what's t over t, everybody? You just destroyed t. T's gone. It's disappeared. It's amazing how many people say that. Where does t actually belong? It's actually the top because this is t over 1. And what I'm doing is your 4th grade math for you. All right, how do you multiply fractions? You multiply the numerators and you multiply the denominators all year long. This is how I teach. Oh, you're going to be sick of it. But I'm not going to do it anywhere. I'm just going to leave it there. I just wanted to ask that question. Equals, and then this one's not so bad, 2 pi over 9. Now, I know what everyone's going to say next. How do I solve for t? Which you're right. Don't be scared to get yelled at. Divide by 5 pi over 27. But it's amazing how many students don't know how to do that. So what would be better? Now it's your turn. Multiply by the reciprocal. Multiply by the reciprocal. Apparently someone couldn't hear. Now, what happens for this? Well, this is no calculator because my teacher's a jerk. So pi's cancel. How many times does 9 go into 27? You can do this across multiplication. And again, I should not feel guilty about teaching you fractions. I should not have to do this, but I am. So you better figure it out. 9 goes into 27 3 times. The pi's cancel. And then how do you multiply fractions? You multiply the numerators. What's 2 times 3? What's 1 times 5? Now, you know what I didn't do and I was bad at? Is I didn't do dimensional analysis. I didn't figure out who canceled as far as the units, because when you cross cancel, it gets all crazy where everything is at. Basically, you just have to remember who did we solve for? T. So what is T going to be in? Minutes. You need to label at the end so you have an idea of what you just found. And that's the best way I can do it, because dimensional analysis gets a little crazy fractionally when we start doing this stuff. Okay, this is question number 2. What? Whoops. That was not online. Nobody knows what I said there. I'll deny it. Deny. Nice drawings. Get a lot done during the notes. Okay, what's V? Well, there's 3 different things there, but what's V stand for? Velocity or linear speed. Okay, and then this one, they actually give you this. But the reason I did this as well, I don't know why. What are we solving for in this? Use the formula V equals RW, find the missing value. You're finding W. What's W stand for? W stands for what? So we're finding angular speed. The dimensional analysis might get lost in the translation. You need to know that you're finding W, which is angular speed, so you need to know how to label it. So that's why I'm covering that. This one's real simple. What goes in for V? 9. What goes in for R? And what goes in for W? W. What do you simply have to do for this? Now, I know I should be doing the dimensional analysis of this, how things cancel. I'm not. W equals 9/5. How is angular speed labeled? What is it? Angle divided by time. What's the angle always have to be in? Radians. Per what? It's second up there, so seconds are going to stay. Now, what would happen, I guess I should do a good job about this, is 9 meters per second, and I divide it by 5 meters. The meters disappear. But here's the problem. The meters cancel what's magically left over. And I told you this. Radians, because radians come from measures when I showed you the 7 inches divided by 7 inches. Remember? Remember, you pick 7, right, for how a radian is generated. That's the magic of it as well in dimensional analysis. When the meters and the meters cancel, what am I left with? Radians, because that's where radians come from. All right, I just got one more, and then I do have to go back to something that kind of jumbles things up. Your homework starts with 4 and 6, I believe. I do those last. Give some space for 4 and 6, and then try to come back to them. But I'm going to talk about this, which kind of leads into what we're doing tomorrow. Hey, I don't know if you ever seen these clocks. Back when I was in high school, all the clocks did this. They spin, right? That's why we can say the word clockwise. Ugh. You know, you guys all have these digital clocks all fancy. You guys know what I'm talking about, right? Okay. Now, this is what I don't like about this. Find W. What's W? Angular speed, which is angle change over time. What I don't like about this question is find the angular speed of the, what does that say? Hour hand. But it doesn't say in terms of what time. The hour hand moves per what? Believe it or not, it does move per hour is easy, but it also moves per minute and second. So I guess what you have to do is just, if it's the hour hand, we're going to do it per hour and make our lives easy. So the bottom is 1 hour. Now, this also has to do with what I'm going to talk about right now. Your dimensional analysis sheet that I gave you, that's part of your homework. A little bit. So listen to what I say about that, because it's going to be a key to your worksheet. Don't you agree that an hour hand goes from, let's say, from 3 o'clock to 4 o'clock, right? In an hour? All right. I asked this question second hour. It didn't go so well. I just need a fraction. What fraction of the whole circle did that just move? No, I just need the fraction. Now, I just need the fraction. 1/12. Right? It moved 1/12. Now, you guys gave me ahead of time the answer, what we're going to end up getting for radians. I just wanted it to be written down in a way that everyone could understand. There's 12 hours on a face of a clock. So this moves 1 hour out of those 12, that space. Okay, now, I know what you guys said as an answer, right? But what's a full rotation? And then this is why people were saying pi over 6. 2 pi. So you do 1/12 of a 2 pi radians. You do 1/12 of a full revolution. For dimensional analysis, 1 rotation equals 2 pi radians. And, if we were going to treat that in a dimensional analysis scenario, that's the fraction. And you could flip them any way you need to for dimensional analysis, multiplying. I just replaced it. 1 rotation equals 12 pi, or 2 pi radians, sorry. And then you go from there. So the final answer is, what's 2 pi over 12? Oh, gosh. And yes, 2 pi does go up on the top. I'm not covering it again. It's pi over 6 rads per hour. And then I do have about 7 minutes to go back to the ones that I said are a little bit weird. Because the way they construct 4 and 6 for your homework, they kind of jumble up the formulas. So you got to be really careful how you read this. I was almost about to cancel them, but if you can get through it, it's fine. So, back to 4 and 6, which I'm going to do number 3. That emulates 4 and 6. Suppose that point P is on a circle. Here's point P. Spinning around the circle. See point P right there? Do you see it? Do you see point P? Class number, period 3. Now, with radius R, and then ray OP is, rotating with it. For the given values of R, W, and T, find the following. Okay, so this isn't specific to the formula. A just says find the angle generated by P in time T. Oh, and by the way, R is given. What's W, by the way? Angular speed. And then what's T? Come on. Time. Okay. Find the angle generated in this time. Find the distance traveled in this time. Find the linear speed of this with the given information. Linear speed would be easy. We could find the linear speed right now. How did I tell you one of the ways you could find linear speed? What's one of the 3 formulas that's direct for letter C? RW. That's it. V equals RW. They're both given. RW. So I don't know. Do the easiest thing you possibly can. It's just the way they break this down is different. So what's angular speed? That is theta divided by t. Do I have those 2 things in this, right? No, I don't need that. No, I'm sorry. I need theta. My bad, dogs. Do you have W? Do you have T? Basically, this is a plug and chug. So know what you're trying to find, know what formula because of what's given, and then it could be placed in there, and then go ahead and solve. So W is pi over 12. It is radians per second, and I'll just talk about it, but I'm not going to write it, equals theta divided by T, which is 6 seconds. Now, radians per second, okay, we'll see what happens next when we know how to solve. How do we solve for theta? It's very easy. What's the opposite of dividing by 6? Multiplying by 6. How do you take 6 times pi over 12? 6 pi over 12, which becomes what? Pi over 2. Now, what's theta supposed to be in? What's the label supposed to be in this? Radians. But I will cover it as far as these labels then. Seconds was down here, but I multiplied both sides by 6 seconds, and I had radians per second. What happens to the label seconds? Cancels. But you don't have to worry about doing that. I just feel bad dimensional analysis wise. The next thing is find the distance traveled by P along the circle. The distance is arc length. All right? So basically, arc length is radius times theta traveled over that time. What's theta? We just found it in the previous one. Pi halves. What's r? What's r? So this is 20 centimeters times the angle traveled over time. Now this is what I mean. 20 centimeters times pi radians. What's the label become? It's magic. Centimeters. Radians get replaced with centimeters because radians come from labels. It's math magic. What's 20 times pi over 2? 10 pi, or 31.4 centimeters approximately. All I did is 3.14 times 10. So if I was an ant, this traveling from here to here, by the way, isn't this pi over 2 when I go from here to here? Right? 90 degrees? I'm just going to, all right, so this would be 31.4 centimeters. That's how much travel time that would be. And then actually for the last one, you know, you travel 10 pi centimeters over how many seconds? What did it say? 6. I forgot the pi. And then you can simply reduce. What's 10 pi over 6 become? 5 pi over 3 centimeters per second. And then you can get it as a decimal. All right, so that just reduces it down to what it is, centimeters per second. Okay, or you could have went all the way back up to the beginning of this question and just done a V equals RW, 20 times pi over 12, and you would have got the same thing. All right? So just be aware of how to deal with that. These 3 questions are also just how do you work with these formulas, but they're asking a little bit different things, you know, how to extract them out. So you got to know which formula to choose, and then find the missing variable and know how to label it at the end. The labels are going to be a key.